technological shifts as a result of investments lead to shifts in production cost structure. In other words, for input-output models, that means that input-output coefficients change as well in the sectoral column. In the Russian Interindustry Model, until recently, technological coefficients were assumed to remain constant in the forecast. This means that technological shifts were not taken into account fully. This year, we take a first step and try to solve this problem. To do so, several methods can be applied. For some of the coefficients, we use just linear trend in the way the technological shift might affect the technological coefficients. And for other coefficients, econometrical approach will be applied, and I will focus on that one. These are technological shifts we considered, and let's look at them. First one is transport electrification. This shift is different for different types of auto transport. In the case of cars, it's very slow, it's even invisible in the case of cars in the side of demand and in the side of supply. In the side of demand, total sales of electric cars yearly is lower than 50 units, while the total car sales is above 1.5 million. So the sales of electric cars is actually nothing. And in the side of supply is also a very low shift, because all the cars that were sold to the households were imported in Russia from other countries. But for other kinds of transport, we have some technological shift. For example, for public transport, we have several companies that produce electric buses, and there is even a company that produce electric batteries for these buses. And in the side of demand, we also have some shift, because many cities of Russia are intend to purchase the electric buses for their transport systems. And for trucks, there are also companies that develop and test them, and it can just develop in the future. Another technological shift that might affect and affects already the production of automobiles is spread of partly and fully autonomous driving. Partly autonomous driving features, you can see them at the slide, are almost the common theme for modern cars. And there are also companies that develop and test software for fully autonomous driving. How these trends will affect the output, the input-output coefficient matrix? Transport electrification influence two sectors of economy primarily. It's production of automobile and land transport services. I will focus on first one. Electrical vehicles uses electric battery instead of internal combustion engine. That means that car producers, instead of purchasing the product of their own sector, purchase the product of a sector of electrical equipment. That means the change in the production cost structure, and coefficient for electrical equipment replaces coefficient that is diagonal. And electric engine that is produced inside the sector of automobile production, made from mostly of copper, while internal combustion engine made mostly from ferrous metals. That means that non-ferrous metals will replace the ferrous metals. Spread of autonomous driving also means that share of electric and communication equipment grows in the cost of automobile. So coefficient for electrical equipment replaces diagonal coefficient, and the same for communication equipment. But how can we know that these technological shifts are occurred? Because it's important to know while we try to approach econometrical regressions. That means we must catch the technological shift in the past and just continue it in the future. As coefficients, technological coefficients, are a reflection of these technological shifts, we might see these technological shifts in them. So let's do that. Here you can see the coefficients for electrical equipment, it's the red line, and coefficient for diagonal coefficient in the sector of production of automobile, it's blue line. They both growing, but the relation of coefficient for electrical equipment to diagonal coefficient is growing over time. That is a reflection of the technological shift we consider. And the same for coefficient for communication equipment. And in the case of metals, the coefficient for non-ferrometals is declining, but relatively it's growing. The other technological shift is digitalization. It can affect almost all sectors of economy and firstly improve management in them. And that leads to decrease in trade and transport margins. And in the terms of coefficient, that means that coefficient for communication replacing coefficients for trade and transport. Let's have a look at some examples. I chose petroleum refining because the share of trade in this sector is quite big. It's almost 10% of output. And we can see that this coefficient is growing over time, it's blue line, but the relation of communication to trade is growing faster. And the same for transport. And I have chosen the machinery case because for machinery we succeeded in building regressions and implied its intertime model. So we can see the same. The last technological shift I will consider is extensive use of composite materials. It might affect different sectors. I will consider construction. The composite materials replace traditional materials in construction that are made from metals and wood. And we can see the reflection of that in the coefficients as well. And for automobile production, we also can see that composite materials replace ferrous metals. Here we can see that. For these coefficients, econometric approach were applied. We used G7 package to make equations, and as an dependent variable, the relation were chosen, and as independent variable, the investments were chosen, because investments leads to technological shifts. And the most appropriate form of investments that has been chosen is calculated investments with 10% retirement, because investments of previous periods are important as well. And this are results of the regression. A red line is predicted values for the relation, and at the right graph we can see the forecast for the relation till 2030. The coefficient that estimated from the relation is was included in the Interindustry Model, in the Russian Interindustry Model, and as we calculated just a relation, one of the coefficients must be get from other method. So in this case, for ferrous metals, we we apply linear trend for ferrous metals, and coefficient for chemicals were calculated as a multiplication of relation to ferrous metals. And here is the result. This procedure will applied for other technological shifts. Here you can see the result for metals. For electrical equipment replaces diagonal coefficient. The coefficient for electrical equipment is growing over time. And the same for communication equipment. And in the case of machinery, digitalization leads to decline in trade, and in transport. In the I'm sorry, this is mistake. In the machinery, not on power production. For other coefficients in the row for communication and trade and transport, we apply just linear trend, and it gives us some effects on the outputs of these sectors. We can see that output of communication is higher than basic line. Basic line, blue line, is for the situation when coefficients will assume to remain constant over time. And for trade and transport, we got a lower forecast. This also has some effect on the macro parameters. The growth of GDP and investments is quite slower and stable. This brings me to conclusion. Firstly, I might notice that this is just the first step. So a lot of problems and a lot of issues I was dealing with while trying to model the coefficients. And as you have noticed, many coefficients were just linearly dynamicized, and this gives me a clue to the future work. Some other variables and other regression must be included in the model to build more fully coefficient system. Also, other methods can be applied. Russia, as a developing country, has a production cost structure that is common for developing countries. But it will change in the future in the way the production cost structure of developed countries already did. Cost structure in developed countries might be a reference point for production cost in Russia. That's it. Thank you.
We will have some time for discussion.
Thank you, Sergey, for your presentation. It was very inspiring. I have a question about the interpretation of your results. So, do you say, basically, that if you become, as economy, become more efficient, you are more digitalized, your management is better, then with the given size of the market, you provide less demand for resources to produce the same amount of product, and that is depressing your GDP growth. So you kind of become more efficient, but your demand is kept, so your growth is slower.
I guess it's for Russia.
But this is right.
Yes, this is right. This is connected with the fact that the products we replace with are mostly imported. They are, and for example, electric batteries are imported from other countries, as well as other electrical equipment. So it might mean, with the import structure we have, that this will depress somehow the economical growth?
This is the general rule.
Sergey, thank you very much for presentation, really very interesting. And my question is about how to allocate composite materials from the flow of chemicals, for example, to production of cars. Because we have a lot of very different types of chemicals, not only composite materials.
I agree. It's one of the issues we must solve in the future because I have not researched it.
Thank you for your presentation. I think you are facing the most difficult question for an economist because you want to ask the question, what is the direction of the innovation and what is the effect of the innovation? You speak about transport electrification and autonomous driving and something like that, something that is happening just now and start maybe 2 years ago, 3 years ago, not 20 years ago. And so I have a general comment that when you use econometric technique, you want to learn from your past. But in your past, there isn't an experience like electrification of the automobiles and autonomous drives. And so it could be difficult to obtain good estimation of something that doesn't happen in the past. For this reason, I think sometimes you can move your coefficient just introducing a different scenario, just making scenario without econometric techniques. And if you want to use econometric techniques, maybe it's better to use something like rolling regression to move the window of the data that you use and not to make a fixed window of the data. But my comment was, my question was another one. When you speak about structural change, you speak about of something that happens not just in the sector that buy something, but also in the sector that produce something. And when you say that car buy telecommunication equipment for autonomous driving, it means that car will change, but also the telecommunication equipment that produce that kind of stuff will change. And so it's difficult for me to understand how to treat the prices of that sector that create completely new product and how do you take into account the price changes during the time?
Honestly, I haven't taken it into account. Yes, I suppose this is one of the problems. Thank you.
My concern is about econometric results. You have strongly in your results autocorrelation because Darwin-Watson statistic is about 1, and this means that this result may be spurious. What is size of your sample in this case?
I don't understand why it's autocorrelated. Dependent variables relation of coefficients and independent variables is investments. Why are they autocorrelated?
But you have residuals also.
What?
Residuals as in average regression, and this may be autocorrelated and autocorrelated, I think.
Okay, I will look through that again and I will check it.
Because in case of autocorrelation, these statistics and other statistics are spurious. You cannot interpret them.
Finally, we have 3 different ways for estimation of structural changes and changes of technological coefficients. The first way is econometrics estimation. The second way is technological measure. If we have some new way, new knowledge about technologies in, for example, digitalization, electric car and so on. And the third one is balanced method, because if we have, for example, energy balance and energy balance forecast for 10, 20 years, of course we have more information about changes of, yes, this slide one. What about econometrical estimations? Of course, we pay attention, first of all, the Maxwell and elasticity, because we understand what equation is good, and we can understand how produce these parameters of equations. And what is not so good, because economical reason not so good, yes, too. But finally, of course, carbon loss and residual and errors autocorrelation is important, and we will develop the system of equation. But finally, it's not only econometrical estimation, it's estimation on the base technological and balance-based calculations, yes.
Well, I have one comment on your nice presentation. Well, do you know that there is a January approach who suggested that all the countries develop the same technological path or similar one. And so you could look at the future of Russia, looking at some countries which are more developed. So my suggestion, and this is rather popular, to use the cross-country statistic, at least for some important technological coefficients: energy, transportation, electricity, and so on. Please think of it.
But electrification is something that is new all around the world.
Yeah, I understand.
So you don't find any country where you can find information about the direction of this
I agree with you. Nevertheless, as some ways it will be used.
I don't know.
Of course, for some of the coefficients, we might apply this method and this reference point, as I already said, but not as Leonardo said, for all of them. Thank you for your question.
I like your presentation very much. I think it's a very important part of the work we've done with our models, and what we're going to do now is very important for the future, to make a good model, to look at the coefficients. And it's not easy to make a good path of coefficients, and for everyone, and because of statistical measures, because of, well, we do not know the future, but it's very important to do it. So I like it very much. And on the other side, when you incorporate price effects, you will have rising GDP on the other side. So the market may grow because of two components. First, because of the rebound due to the price shifts going down, more efficiency, lower prices, and you have more GDP on the one side. On the other side, maybe you have new products, and then GDP will also go up. So it's very important to look at both sides, the coefficients and the price side, the rebound side. and the new markets maybe. So I like it very much. Thank you.
Thank you.
Yes, I also like your presentation very much, and I think this is a rich field for research, because we're often being asked questions about the future, and especially future technologies, certain cluster of technologies. What does this mean for the structure of the economy? I wanted to make one suggestion. One thing that we've been doing in our shop is, instead of a linear trend or any kind of a trend that keeps on growing like this, using a S-curve, logistic curve, because this one, it's something you can fit with econometric equation, but it will, at some point, it will flatten out, which is what many people think technology does. There's first a period of slow growth, slow adaptation, the early adapters, and then the rapid adaptation becomes more the common technology, and then finally becoming mature and petering out. So we've been using this logistic curve with, I'd say, some success. It's not always perfect, but at least the coefficients don't go off into infinity. Because if you take the linear one out too far, it's going to be very large.
Yes, I know.
And the other is on the question of the autocorrelation. G7 has a way of automatically adjusting for this. So we understand it's a problem, but it's a problem more in terms of how do you want to make the forecast. So if you know you have autocorrelation, you have this value of rho, it might be very high, close to 1 perhaps. G7 can adjust the forecast by this so-called rho adjustment. It's described in the craft of economic modeling, and it's a standard part of the forecast mode in G7. And you have to be a little bit careful with it, however, because if the last miss of your equation was very large, if these are very volatile coefficients, and you just happen to have a big error on the very last observation, it's going to make a smooth, adjustment back to the regression line very slowly over time. And so this rho adjustment will in fact end up being your entire forecast, which maybe is not what you want.
Yeah.
But it's a hard thing to decide, what do I do with that error? Do I go right immediately back to the regression line, or do I adjust slowly? It's a subjective decision. There's no right answer.
Thank you.
When it's big structural jumps, things like that, what us doing is what we add another sector. Now, let me give you an example. In South Africa, you can make petrol, or from coal, or you can do it from crude oil, or you can do it from gas. Now, then it's very difficult to bring it in and to get your impact. So for me, it's the easiest is to have it in the end of the day, try to have rather 3 subsectors and do it from that way. But this is not really now in line with what you do.
Thank you.
Okay, next question. Yeah, thank you very much.
Thank you.
And the second